Hi everyone, are you able to hear me and see the screen clearly? Hi Elvin, hi Alok, hi Aniket, hi Vintao, hi David, hi Grishma, hi Hitendra, hi Jay, Maruk, Noor, Ravi, Robin, and Shravanti. Good to have all of you in the session. All right, so where were we in the last session? We were talking about this part, right? Great. Great to have all of you in the session. And also I wanted to walk you through this in the CloudxLab, right? So in the CloudxLab, under your courses, when you go to my course, okay, under your courses, you will get your course, whichever you are planning to attend. When you go into it, you'll notice that these are the various your progresses. See, I've not marked this complete here. It's 20% and so on. Now here, the slides of the courses are also available in the topic. For example, if I go to Zookeeper, so these are the various questions, exercises, and videos which I can linearly finish, or I can jump to a particular topic. Also, towards the end, you can click on resources. In the resources, you can get the slides. Okay. So the last section of every course is bunch of slides. Okay. Now that was a quick idea about what it is. So similarly, for any course, you can actually access the slide. Okay. Say, for example, you want to go for, say, yarn, you can click on start now. And then under that, you could go to resources again, and there you will get the slides. Great. So for all of the content that we discuss here, what we did was we recorded everything in the studio and kept it there. So it is up to you whether you want to go through a video or not. Okay. And it's up to you, but do attempt the questions. It is basically you can just mark it done and then go. So the idea here is that let's say this session is finished and you want to quickly recap everything. Okay. And it is basically just if you have learned something already and we learn about race condition and this, you can just mark it completed and then go to the next one. Okay. Then we talk about deadlock. If you know about deadlock, you can keep on going already, right? Then these exercises are important. Okay. So even after this class, that is a quick way to do revision. It's up to you whether you want to go back and study or you just want to skip all of this. All right. A question from David is that there is no text for the yarn class. Let me see if we can update the yarn class and put the text there. Okay. So we have some text here and then exercises. Okay. Then the next topic is this. There's some text here, right? So one more thing, the icon in this would be a quick way to jump, right? This means multiple choice question. This means video. And this means, okay, there is no hands-on in this one. Okay. It wasn't showing you that. Okay, let me see if it shows in other browsers. Okay. Is it showing today? If you go into this. All right. Just let me know, because this could be a difference in the rendering in the browsers. So we would love to understand what is wrong with that and then take a look at it. Okay, wonderful, wonderful. A question from Intao is, will we still learn topic 9 and 10 in the CloudxLab? Okay, the topic 9 and 10 is MapReduce Basic and MapReduce Programming. Okay, 9 and 11. I think that's your question, right? So this we will not learn. This is optional, right? And should I just change the title of this one to optional? Okay, and this one is optional. Along with that, this one is also optional. All right. So, okay. So basically, it is up to you whether you want to learn MapReduce programming or not. Okay. So, okay. So it is up to you, absolutely up to you, whether you want to learn MapReduce programming or Java this. But we will cover the basics of it. We will not go into the advanced programming, as well as we will not cover Pig and Latin in the live class. But we have provided you the recordings, so you could go through those. Okay. So, but we'll talk about 9. Question from Noor is, from which topic we'll have project? We'll have project from here. Okay, from Hive. We have exercises on every topic, and from here we'll have the project. Okay, so the important idea is that for every topic, do finish all the exercises. Okay, uh, and this one, the 5th, 10th, and 11th is optional. Okay, while rest of it is mandatory. A question from Robin. I'm just curious, will Pig Latin will be discussed in other classes like Spark? We won't be going through that because in Spark is independent of Pig Latin, but can get everything done using Pig and Pig Latin. Sorry, can get everything done what Pig and Pig Latin would do. Okay, so Spark, with the Spark, you could achieve anything that could be done with Pig Latin. Okay. So Pig Latin is a language, Pig is the executor. So, and question from Binta is that Pig is also popular. Why is it skipped? Basically, the Pig, to be very, very honest, okay, so Pig is not being used much. And there is a very valid reason. The reason is that the Pig guys, they tried to create their own language. The language was quite restrictive, and therefore the language did not get adopted so quickly, though and therefore and I remember I was working with one of the consulting works that I was helping with Society General. So they came up with that, okay, they want to load certain data, and the data's columns are in separate file, and there are 100 columns to be loaded. And when we looked at doing it using Pig Latin, it became really difficult. And the same thing happened in one more consulting project that I was helping with. And eventually we moved to Spark. So that is my personal experience. And industry also, people are probably moving to Spark. They already moved to Spark from Pig for the same reasons. Okay. But it's not difficult. You can just go through it. If you have doubts, just give me a ping. I or one of my teammates could also help. Okay. A question from David is regarding the overlap between the tools. So I try to create something here. Let me just walk you through it. And if this sounds okay, or somebody wants to contribute to it, then I can give you the mind map and you can edit it. Okay, so let me just show you what I mean here. You see, Okay. Now, this is the ecosystem of big data tools, right? You have various NoSQLs, there is HBase, there is MongoDB, there is Cassandra, there is CouchDB, Redis, Amazon Redshift, Zookeeper, message queues, there is Kafka, ZMQ, and these are the three most popular ones. Workflow, people use Uzi mostly, Azkaban or this are kind of not used. Okay, we used Azkaban, and nowadays it's used Uzi. And the okay, so this is one diagram that I created. I'll share it with you. If any of you wants to contribute to it, you can help me out. Okay, so where should I upload it to? I'll just upload it to Google Drive. Okay. Here we have, okay, I'm just putting it in live session screenshots. Okay, so let me just save it to Google Drive, and from there it will be available to you. Good. Now let me just open Google Drive and share it with all of you so that it's available to all of us. Okay, the Google Drive is kind of paused. I just resumed it. I'm hoping that will sync. It's taking some time to synchronize. Okay. Okay, so question from Robin is, what are the main functions again of Pig and Spark for big data? Pig and Spark are used for, let me just show you in this diagram. Okay, they are basically for ETL, okay, for analysis of the data. Okay, so Pig actually was used here as well. So for ETL as well as analytics, Pig was used in both the places. Okay, so basically these are the kind of compute engines, the way we look at it. They come and they are for batch processing and specifically for analytics and ETL. Okay, yes, so log parsing is just one specific use case, but you could do other things as well. Okay, ETL is for all kinds of data transformations. Okay, so David, yes, looks like that this diagram could be useful to us. I can right now see the use cases. Okay, so here, this is where we have put the mind map. All right, so what would be this one? I'm just giving a link so that anybody can access. All right, so this is the image. And this is, should I just add, if I'll just give you the link, okay? And let me just see if you want the modification per this thing. All right. If you want access to, this is the mind map. There is a tool called FreeMind. I use FreeMind to create these mind maps. And these are quite good to quite easy tools to visually create these charts and graphs and kind of put down your thoughts in the form of graph. So if you, instead of lists, this sometimes comes very handy and can be very useful. Okay, so you could use FreeMind, which is open source tool for editing, and there are these tools in Google Drive also. You can see there is something called MindMister and so on. Okay, so connect more apps. All right. So there are quite a few tools that there are available. I'll just give you the link so that you can, if you want to modify, you can modify and let me know that. Okay. All right. So great, great. And let's go. All right. Let me give recording permission to Sachin. Anybody else wants the permission to record so that we can start now? Question from Robin is that I would be glad to learn and use Spark on big data. May I ask if I can also apply Spark for Splunk data instances? You should be able to do that. Okay, Spark for Splunk data instances, right? So I think basically you should be able to uh, do that. Okay, let me see, because I have not worked with Splunk yet. Let me just put a note to myself. Okay, where does Splunk fit in? Okay, that's a note to myself. And the class is 24th Fab, big data. Okay, so great, great. So let's, yeah. Those who want to update this, feel free to update, put the notes, and we will publish it. Maybe put it in our Git repository somewhere, and that should be good. Okay, wonderful. All right, all right. So we'll basically create this graph so that we can quickly, look at things and take a look at what lies where. Although it's going to be simplistic and therefore maybe not be very accurate, but it will be a good reference. Now, so till last time, what are the things that we discussed? Things that we discussed was the architecture of yarn, right? What is the purpose of yarn? So you have many computers. You have many computers in your cluster, right? And what you want from these computers is that whatever program do you want to run, you should be able to run on the number of computers you want, correct? That is the sole objective. The objective is that when you want to do, when we want to run a program on, say, 3 machines out of 50, we should be able to run. Similarly, what's the objective of yarn? The second objective could be that we want to run our program nearer to this data. This particular data file would be having these data blocks, and therefore we want to run on those machines where the data blocks lie, correct? The third thing could be that we want to keep running our program forever, right? That too on many machines parallelly. Like in case of NoSQL or say HBase, we want to run our program parallelly. That is the another objective of yarn. So, okay, let me, okay, all right. A question from Minta is, I cannot open this second link. Alok, yes, please go ahead to unmute before I move forward to Jan.
Yeah, yeah, Sandeep, just one thing.
Mm-hmm.
Like, can we have any session like we? I can understand like the how to create the cluster.
Mm-hmm.
Just what happened with me means last few days back in my office, they
Mm-hmm.
asked me to create one HDFS
Okay.
configuration cluster and for Kafka cluster one to one. So I feel very sad, like I am not able to do that. I am not
Okay.
hands-on on that. So just I am looking like if we have one session for all these kind of clustering and how can I do manually create and feel good like I am able to do that. I know how to install and I to do that, then run the program and see that. So running program it up to us, but I want to see like how to create all those things, how to interconnect that. I did something,
Yeah,
but
good,
it is
good.
like it
Yeah,
is
that's
not feeling me good like that day,
okay.
and I am struggle so much, but
Okay.
still it does not work with me.
Okay.
So
Okay. So
that
let's schedule a 3 hour session. Okay. 3 hour session, and let it be handled by my teammate Abhinav. I will be there in the session. He will be leading it. Okay, because he owns most of the DevOps. Okay. Now, right. So let's just schedule a 3 hour session, and all of the people are invited along with our previous uh, participants and this class participant. Let's schedule this 3 hour session, and if not this week, because we might for this is because we need to get an Amazon account to show you that how it is done on multiple computers. So we would
yes, yes.
like to basically create a separate account. That might be little costly to us, but it'll be easy to give the entire demonstration. All right, so we will do that probably next this coming week, and there we will record that also and maybe publish it to everyone if they want to do, because what we found was that it won't be difficult to set up the cluster. And okay, and yes, thank you, Prashant, for knowing that. So yeah, we can actually use the Google Cloud, and they have a $300 free credit. Okay, so yeah, we can do that. Let's because it won't be too technical. It won't be too technical, and it will be quite easy and straightforward. So
But sometimes Sandeep, it is happen like you feel like very bad,
yeah,
like you have
yeah,
to
yeah,
ask to somebody like
correct,
how do
correct,
I do that? Because first time I'm
correct,
doing all these things.
right,
So
right,
in the
right.
office, it is not feeling like I am doing the learning, also doing the course. I'm
Okay,
practicing, but I'm not
correct.
able to do like it will frustrating
Hmm,
kind of things happen.
hmm, hmm, hmm,
So
hmm.
that is why I ask.
Okay, so let's do it this week itself, towards maybe Thursday or th Thursday, uh, or if Wednesday is possible, let me discuss internally. Okay, coming Thursday and Wednesday, same time, right? 8 p.m.
Yes.
8 p.m. IST is okay with all, right?
Uh,
Do, for others, is it okay to do the or during the weekday? Uh, this session, this one, this session will be recorded and okay,
Wednesday, if it is possible, can we make it Thursday? Like,
okay,
because Wednesday in my office call, it is US from 9 to 11, like
okay.
that.
So a question to all of you: Wednesday or Thursday?
So for me, it is Thursday.
Okay, okay. How do you? It's such a long process to create a question, right? So let me see if it looks like okay. It takes a long time to create a poll here. Okay, never mind. So I just did. All right, so this is useful. This is useful. It's important to have these feedbacks, and that's how we all improve. And life as an instructor becomes more interesting if there are deviations and there are new things to do in the class. So therefore, it's important to make the exceptions. Okay. Yeah, Prashant, I could have done that. So, all right. So I think looks like people are okay with Thursday, and so far the pool is like mostly Thursday. So, all right. Subinta is also okay with Thursday. All right. So, okay, okay. Great, great. So what we are going to do is in this 3 hour session, we'll work hard to make it more lively. So this time what we'll do is me and Abhinav, both of us will basically be creating an entire cluster for all of you, and we'll set it up so that we can demonstrate to you. So it'll be 8 p.m. to 11 p.m. Okay. So, all right, great, great. So I think Thursday is final for us. I don't think much credits will be required. Maybe like $10, $50, $10 to $15 will be required. Okay, so no worries. So Thursday, what we are going to do is we are going to have 3 hour 6-star session on creating the entire Hadoop cluster on either Google Cloud or on Amazon Cloud. Okay. All right, wonderful. No worries. So we'll take care of that. Great. So cool. Right. So we'll actually go with AWS. That's thank you, Prasant, for coming with that point. That mostly people actually prefer AWS over Google as of now, and therefore we personally also prefer AWS over Google. Though Google is cheaper in terms of cost, and the massive scaling of our CloudxLab, the next generation, next step, which we are working on, in which it can support to thousands of users parallelly. We are we are experimenting with the one with Google and AWS. So we are still using AWS. All right, great, great. All right, so okay, so David is going to be at Disney. Nice. Will the recorded session be uploaded for the reference? Yes, of course. Okay. Thank you. Thank you, Noor, and thank you, Prasant. All right. It'll be uploaded in the my courses itself, okay, as well as on YouTube. Wonderful, wonderful. So great, great. Now, all right. So what we were talking about was the yarn. Should we start with the yarn now? Okay. All right. All right. I think there has to be more communication in the class. So feel free to ask questions. Feel free to, you know, put down the points. That's the only way you can walk out with some knowledge. Okay. The only way to remember or to understand something is by questioning it aggressively. So my humble request to all of you would be to work on questioning anything, and that's the only way to learn. Okay. because by questioning, you are basically helping the class instead of stopping the class. All right, because all of these content that you see here is available all around internet. These sessions are meant for answering your questions. Wonderful, wonderful, great. So okay, so sure, Robin, I'll take a look at the AWS. Okay, okay, so that'll be useful actually. Your free account will be useful. And let's see. Great. So what we have is, in case of Yarn, that we have, let's say, multiple computers, one computer, another computer, and third computer, and and yes. So this is the architecture. We are going to do a recap. So what the objective of the Yarn is that, let's say we have many computers, or should I do the sketch? I think that'll be easy to explain. Why are we talking about this one? Technically, from the course point of view, we will need to learn this, because when we talk about Spark, this will become more clear to you that it runs on Yarn this way. Okay, as well as a general knowledge, we must know what is there, so that in the environment, when you are executing your job and you see that something is failing in Yarn, you will know clearly that what's going on. Okay, so the terms have to be clear. What does it mean by each term, right? So let's say you have these computers, right? Three computers, and what you want is, you want to execute something parallelly on these machines. What does it mean by execution? Let's say you have many images, you want to resize all of those, or let's say you have huge number of log files, and you would like to extract information from those log files. Log files as in the server log files. You want to find out on what time most of the users are logging in, and so on. So basically, the analytics, or whether heavy loads such as image resizing, or let's say recommendation generation, or other things. So let's say you have three computers and you would like to divide the work on these three computers. In simple words, you want to run something on these three computers parallelly, right? So creating your own platform would be hard from the beginning, because there are many things. One, executing something on multiple computers, respecting the local files, respecting the JVM, and in case this one goes down, executing something on some other computer, right? Also, locating where is the data and executing nearer to the data would be really important. Third is, if you have many such programs in the cluster, right? If you have many such programs in the cluster, then what you have to do is you have to track who is executing where, and which machines are free, which machines are busy, and which machines are terribly occupied. So those kind of things you will have to observe. Okay, so basically the objective of Yarn is to distribute the work such that it gets executed as per your needs, but on the machines which are free. Okay, so if we need to design such kind of system by ourselves, it's going to take a lot of time. All right, so that was the sole idea behind Yarn. Therefore, once Yarn was designed, almost every application started using it to run itself. Okay, so it's like running program instead of on your computer, on other computers, and that is decided by Yarn how to run, where to run. You just give your program executable along with all the things that it depends upon, and Yarn takes it and executes it. Just that to work with Yarn, you need to interact with Yarn in a certain fashion. Okay, in a certain fashion. So you have to design two parts to it while giving to Yarn. One is called client, other is called master, application master. So you have to design application master, and this application master must know how to talk to resource manager. So you generally do not design the application for Yarn. Instead, you use existing systems such as MapReduce, Spark, in order to talk to Yarn. Because this entire dynamics is a little harder. Like you will have to create one software piece of software called application master, which will talk to resource manager. Resource manager will respond, and then you will application master will decide how many containers. So therefore, designing an application for Yarn is a little harder. Therefore, you generally use the third party, the tools like Spark or MapReduce. Okay. All right. So a question from Robin is, with respect to Yarn, how do we select the computers? For example, selecting 3 out of 50, where we want to run the program. Correct. That we are going to talk about next. On what components do we need to set them? Client, resource manager, node manager, etc. and how? Correct. Let me explain that. Okay. So where does RM reside? We'll talk about this. Okay. So Yarn works like balancing load across machines by distributing the request. That's correct. So next question is, where is these components reside? So as a general thumb rule, if you have n number of computers, let's say you have 50 computers in your cluster, and these 50 computers, you are okay with running programs on them. Generally, wherever you have data node, you should be running the programs because you don't want to transfer the data, instead running the logic nearer to the data. So instead of taking the wood to the X, we take the X to the wood, meaning instead of carrying the data to the processor, to the computer, to the program, we take the program and run it nearer to the data. Okay, that's the biggest difference between Yarn and others. So the the so it is clear that wherever there is data, we need to create a node manager, because node manager is the one which is going to create containers and execute, right? So wherever is the data, we create node managers. All right, because node manager is the one who is responsible to execute containers. So node manager is a service, resource manager is a service, while containers and app masters, they are containers is basically a temporary process which is started and then dies down, while application master runs inside the container. Again, that's a process, and it works and then dies down. Okay, so node manager and resource manager are the services. Okay, while the containers and client, these are processes. Okay, so what we do generally is, in the cluster on all the machines wherever you have installed data node, if it is free and is capable enough to execute something, then you make that node manager. Okay, and then on either separate machine or the machine that is running, say, name node, we generally put resource manager. But putting resource manager on the same machine as name node, it becomes just too much for that machine, because resource manager also does a lot of work. Name node also does a lot of work. If you have like a big cluster, then it is generally preferable to keep resource manager and node manager, resource manager and name node on the separate machines. Okay, but resource manager knows about name node. Okay, resource manager knows about name node. Wonderful. Is everybody with me so far? Okay, resource manager is a part of Yarn. Resource manager is a service, node manager is a service, node manager is like slaves, and resource manager is like master. Okay, so client is, yes, client is basically MapReduce job or Spark job or some other H-based job or something like that. Okay, so all right. So question is, what is the most acceptable time frame for a container, an app master to load request into it temporarily? That time frame is generally decided by the client. Okay, and that's how it generally works. So here we take the a time lag of say 1 to 2 seconds, honestly, because there's always a lag between creating containers and executing them. Okay, so a question from Sachin is, can you repeat the architecture of yarn? This is yarn 2.x only. Okay, so I'll go ahead once more. So whatever machines you have in your cluster, wherever you have put the data node, you generally put something called node manager. Node manager is a service which keeps running in the backend. On one of the machines, such as name node or separate machine, we put resource manager. Client talks to the resource manager. Resource manager talks to the node managers. And after discussing with them, the first thing resource manager does is creates a container for head office, meaning application master. Per application, it creates an application master. The moment it creates this application master container, rest of the work is done by the application master container. Okay, so when we will learn with Spark, we will learn that how to execute Spark jobs such that application master is created. Okay, so here basically the idea is that most of the work that needs to be done by the client should be moved to the application master. Okay, so that in case this client dies, right, still the job keeps on running, because in case application master dies, it will create it somewhere else. So it says that the client itself, the work of the client should also be done in the cluster, right? It's like opening the head office for a company because it's just too much of work back and forth between the client. All right, so that's the general idea. The other reason is that, let's say you want to run a program like HBase, a database on the cluster. So there also, resource manager would like to launch HBase master or something in the cluster inside containers. Okay, so that's the reason why there is a application master concept. Okay, so client comes to resource manager and asks that, hey, we want to do something. So resource manager talks to all the node managers that, hey, this particular client wants to use this much memory, this much CPU, and do you have some time? So node manager says, yes, we have time. And then resource manager asks them, then can you please start creating a container for them? And the container is where the work happens, right? Container is a process. Then inside the container, rest of the work happens. Okay, so container is a process, runs a client workload and enforces security on the client process, memory consumption, and resource access. Okay, so this is the process that we talked about. I'll go over this. Instead, I'll just describe the architecture again. So you have, say, two kind of clients. Let me just give you a view from the country's perspective. So you have two kind of clients. Okay, there are a few questions. Let me just go over them quickly. Most of these are okay, is simple. So question is, what is the, okay, that one is done. Can you again repeat the architecture? Yes, that's what we are doing. Question from Aniket is, what if the machine that has RM goes down? That's right. In this case, the process will stop, and therefore you generally keep a backup of RM. Okay, so so resource manager can be load balanced or yeah. Okay. Now as of now, we have not in our cluster, we have not done the resource manager load balancing. Okay. A question from Noor is, I don't understand one thing. If node manager is talking to resource manager, then why app master is talking to resource manager? Good question. So the app master is nothing but a container, right? It's basically like a head office. So the idea, it's a very important idea that The general idea earlier was that client comes to the resource manager creates a container on one of the nodes, and when work gets done, the it returns to the client. Now that kind of architecture where there is no app master is not really scalable. Okay, reason being there could be some jobs which run for hours, there could be some job in which we want to run the process in the background and so on. Therefore, it was very much required that the job of client should also be done inside one of the containers. Okay, so client is kind of a very thin client, hands over the work to resource manager launches it and gets it done. uh, then app master, kind of the first process that is created, that becomes the representative of the client. Okay, and afterwards rest of the work is done by app master. Just like client was asking resource manager to create a container, app master will ask resource manager to create more containers. Okay, so that's the reason. All right, so that was a question from Noor. Did I answer your question, Noor? Okay. Question from Grishma is that every data node has node manager. Generally, that's the idea that we try to work on. We intend to put node manager on all data nodes. Reason is we want to process data then and there on the same machine, because reading data from the local hard disk is faster than reading data from network. Okay, so a question from Robin. So you mean the time is set at the client? I'm curious where inside the client do we set them? We'll talk about this very soon. Okay, because we'll talk about there are three kinds of processes: one long running, one short running, and one running for a session. And there the client decides which one they want to be. Okay. A question from Sachin is, so Yarn do the parallel processing? Yes. So we basically give the program, Yarn executes it on multiple machines, and that's how it is. Okay. So do we have to start services resource manager and node manager? So in our case, these are pre-installed and these are basically forever running. So resource manager and node managers are continuously running in the background. Even if there is no client, even if there's nothing happening, they will still run and wait for the client to come. Okay, node manager will keep a track of what's happening on that computer, and resource manager will keep a track of what's the status of various node managers. Okay, and that happens by node managers reporting back to the resource manager. Now, so next question is, if the client dies, why will it request still handled, right? There are many kind of jobs. Some we want to run in the background, some we want to run for the session, some we want to run forever 24/7. So some we want to just get it immediately done. So there are all kinds of requests, right? Therefore, it's very, very important to have the provision for all possibilities, correct? And this architecture gives that possibility. Okay. Question from Noor, why Node Manager 3 doesn't have App Master in this case? Okay, because there are only two clients, correct? There are only two clients, and for two clients, we just need two App Masters. The App Master is per client. Okay. So Node Manager is per machine, okay? And the App Master is per client. Okay, and the next question is why there is the third one has two containers. The third one has two containers. So you can think of it as that every client is different. Every client is different. This client once has bigger data to process, therefore it wanted more containers, and therefore it got 3 containers. So this app master got 3 containers, 1, 2, 3. The fourth container is for app master itself. All right, this one has a small file to process, so it only got 1 container. It's up to the request of the client. Okay. So one one node manager can have multiple containers, yes, based on how much memory that computer has and how much memory we have allocated to the container. So if let's say we have allocated 1 GB to each containers and we have 16 GB available for each node manager, then basically it can host up to 16 containers. A question from Sachin is, do we need to write a code for processing? Do we need to write the code for processing? Yes. So basically client could be many. There could be MapReduce. Now it's up to MapReduce. They could create one more layer whereby you don't need to write the code. You can just write the SQL queries and that should be good enough. Okay. Like for example, in case of a Hive basically uses MapReduce client. So when Hive's queries, so there you can write the entire logic using SQL and it's up to us. Okay, like in case of Scoop, what a Scoop does is you don't need to even write the code. You just run the command, and that one internally will generate the MapReduce and call the MapReduce, and rest of the things will happen. So basically, instead of you creating the client, you use the existing clients. Okay. So both services, Resource Manager and Node Manager, they are kind of central. Yes. This one is a singular one, while there are multiple Node Manager. Okay. Can you explain the difference between container and application master? Application master runs inside the container. Okay. So application master is a software that is running inside the container. And container is basically like office boundaries created by the node manager. Okay. So node manager is like governor of the state, and you go to governor, hey, we need one head office. So governor says, okay, fine, head office is still an office, meaning app master is still a container, and therefore it creates office for you, meaning the container for you, and there you open the head office. Now head office starts talking to the president or the resource manager, and then rest of the communication happen. All right. So what is the container? The important question is why do we need an idea of container? Container is the one which enforces the constraints provided by the governor, as in the node manager. So node manager enforces constraints like, hey, you cannot use more than 1 GB. So that kind of constraints are enforced by the container. When application master is running inside container, and application master is a foreign code, right? Application master as well as this logic is a foreign code, right? So this foreign code might misbehave. Therefore, container is like a virtual machine running here and and enforcing and constraining the application master. Okay. So while container is the software from node manager, it's a program which is from the node manager, it's like a virtual machine, and the application master is running inside the container. Good, very good set of questions. What are the other differences between app master and the container? Where are they physically located? What is the cost? Okay, so basically these are programs, right? It's like when you double click calculator, right? It's like when you double click Chrome, it opens the Chrome, right? That's the inside it. That's what is happening. You're opening a program. That's a program running. Inside the program, you're opening further another program, and that's how it is. So Node Manager is creating container for you. Inside that container, you could run your app master, or first it will run the app master, and then you can run anything of your choice. Okay, in case of MapReduce, some mappers will be run here. Once mappers are finished, then it'll launch the reducers inside the container. So map and reduce both will run inside containers. Okay, we'll talk about this later today. Okay, so a question from Noor. App master acts as a proxy to the client. Yes, and just communicate at the client level, but actual work is done in the other containers. That's right. And number of containers will depend on how many separate programs are requested. How many, basically, it will depend upon uh, the request of the client. I'll talk about how does the request of the client look like. So if we are running two programs in Spark, then Spark App Master would start two containers. Okay, I'll show you. So there is something called resource request. It's like request for execution when you are writing to a government authority that, hey, we want to establish our offices and so on. So you specify what is it that you're looking for. In the same way, when you are asking Yarn that, hey, we want to run this particular program, so you tell it that how many containers you would request. Do you want it upfront or on the go? Right? Similarly, you will also say, hey, we require this much memory, this much CPU, these many locality constraints for each of the containers. Okay. And we also say that, do we want it upfront or do we want it as we go? As we go means remaining of the container request will be done by the app master. Okay. The app master would further give the resource request. Okay. So this is the resource request, the way it looks like. Okay, so we basically tell locality constraint is an important criteria. We tell that, hey, we want the containers nearer to this data. We want the containers nearer to this data. That's a locality constraint. Okay, so we tell the yarn that, hey, we want these many containers, and each container must have this much memory, this much CPU, and the locality constraints are these. And we would need it as we go as well. We'll ask for more at later point of time. Then the application lifespan can vary too dramatically. So lifespan is categorized into three categories. The simplest case is one application per job. Okay, there could be many different applications having different lifespan, right? One is the program like what do you say? Let's say you are executing a command, you press the enter, it is doing something, and it finishes, and the program finishes. That's the simplest case, right? That we call as batch job. There could be another software that you double click and it runs in the background. It keeps running forever until you stop it, like in the case of a database, right? That is long running application, right? There could be other applications like command prompt. When you open a command prompt, it keeps on asking you commands and you keep on entering it. So there it could be one application per workflow or user session. Okay, so there are basically three kinds of lifespans in general. Okay, and while creating a software or a program that interacts directly with the yarn, you will be creating this. A question from Binta is, what is Apache slide and Impala? Let me just go explain it in the next slide. Okay. So first, know that building Yarn application is hard, right? So this architecture is nice to know, but we won't be using it much. As such, we won't be creating a client by ourselves. Instead, we will be banking upon the existing frameworks such as MapReduce and Spark. Second, we will try to utilize existing tools to build jobs. Okay, there are these existing projects such as Apache Slider. What it does is it makes you run any Java application, any distributed application on the cluster inside Yarn. So So for example, let's say you have some tool already running normally, and you would like to run inside the yarn, you could use Apache Slider. Okay. Then second one is Apache Twill. It basically runs the Java runnable everywhere. Mostly for most of the ETL work, most of the processing work, or most of the computational work, you can actually get it done using MapReduce or Spark. Okay. Otherwise, if these are not sufficing and you would like to run your entire software here, you could use either Apache Slider or Apache Twill. Otherwise, if this is also not good enough for you, know that building a application which talks natively to Yarn is complex. And the best way to start building would be using a shell application. There is a distributed shell application which is there, which you can use. Okay, so that's basically what the Yarn is. Okay, so that was the Yarn. I think I was able to clear. A further question from Binta is that what is Impala? So yeah, Impala is basically, I think Impala is the one that converts Hive queries in case of Cloudera distribution into MapReduce. Okay, we'll go over that as we go ahead. I'll just keep it in my to-do list to discuss about it when we. Okay. A question from Sachin is that why there are two containers. Actually, there are three containers in the second one. You see, which client it is? Microsoft. For Microsoft client, he came to resource manager. Then resource manager allocated the head office for Microsoft. This Microsoft head office or the application master, the main one, okay, could be it needs more work, more processing. So we have created three containers. Okay, the last one has two containers. Maybe the file that it is processing, this file is located on the third machine, all the files, and their data blocks are here. Therefore, it has created the containers nearby that. Or maybe at this point of time, only this machine was free for the next container, and therefore it gave it that container. Okay, there could be these two reasons. Did it make sense to you, Sachin? Right. So yeah. So application master also runs inside container. There are all kinds of workloads that are run inside container. Container is a general boundary. So it's like saying that whatever is the kind of office, whatever is the kind of work that is done, it is done inside the office. Whether it's a head office or normal branch office or the workshop, everything is a office, right? In the same way, whether it's app master or whether it's doing the actual data processing or whether it's running MapReduce or whether it's running the Spark job, everything is a container. All right. Yes, so the client could be MapReduce, client could be Spark, and client could be some other framework. All right, good, great set of question. Grisma was able to answer your question. And Sachin? Okay. Question from Robin. With respect to migrating from existing old cluster management system into Yarn, will the migration to Yarn be a non-impact to existing client request? If there is an impact to existing client request, what is the best way to plan for migration to Yarn? Wow, this is a good question. This is a good question. Let's say we were using some other resource manager earlier and we would like to replace that with Yarn. Know that you will have to essentially create the proxy, your own proxy client, which can handle the similar workloads. Okay, so you'll have to basically use the Apache slider kind of a shell, kind of a beginning application to create a proxy so that the clients, your clients would continue to use the system. Otherwise, otherwise, it'll be really hard because here, if let's say you were using some other framework and you want to move here, what would happen is you would you would either use Spark or MapReduce, correct? So if you're not using Spark and if you're using Spark and MapReduce, you will have to rewrite all of the client applications. Okay, and otherwise, if you have a certain way of doing things, then you will be you would better write a framework parallel to what we have. Basically, this is where you will have to you'll have to create using any of this. So there'll be, okay. So basically you'll have to write a kind of a layer whereby the existing older client. So let's say you have the clients for your old framework. So the older clients, because you can't change all the clients right now, right? Because the migration has to happen. All the code needs to be rewritten. If you, let's say there was a way, I'll talk about a specific case. Let's say at DShaw, we were having our own grid computing system in which we will submit our script jobs, and those script jobs had a certain way of execution. And there were thousands of such script jobs that we had created for grid execution. Okay, and later on, let's say we had to move that to Spark. Let's say we had to move that Spark by installing a Spark on all the machines, or just move the cluster to Hadoop and get that executed. So in that case, we will have to either use, say, Apache Slider or Apache Twill to create kind of a proxy or kind of a wrapper, okay, which would be used by the older systems. Okay, so that's how it happened with YARN 1 and MapReduce 1 and 2. MapReduce 1 was perfectly fine, everything was running fine. The only thing they did was the framework they extracted separately, and MapReduce basically this framework accepted the older code, and then this MapReduce is what was written separately, so that the older requests, older MapReduce jobs can be happily executed on YARN without user needing to change the code. Okay, I hope that answers your question. So the actual code, processing code will be yours, the client. Basically, client is generally the framework. YARN's clients are generally the framework. The actual client calls the framework, which interacts with YARN and then gets the work done. Okay. So the question is, you mean the old framework can coexist with YARN temporarily during migration? That's right. And does a Spark script program have to write code? Does a Spark script have to write code to handle YARN considerations? Mm, okay. Does one have, as in you mean to say that, do we have to write the code to keep the YARN in consideration, right? A very good question. So question is that we know that this is what is going to happen, right? So we know that this is what is happening inside. Do we need to worry about this? So it's good to know what is that the program that you are running is going to run on multiple machines. Okay, I'll give you a very good example here. This is a very important example. Okay, so imagine that you are using Scoop to import data, or let's say, I'll explain actually. This is a very important question, and this is something that you'll face as well when you go into production, right? So let's say you have your happy looking MySQL database. Okay, this is your MySQL database, which has something, and then you want to move this data to, say, HDFS. Okay, we saw HDFS. In HDFS, we want to move it as, say, CSV file. Okay, we want to move the HDFS, the table from here to here. Okay. Now, one way is just export this table to a file and then do a Hadoop FS copy from local. Right, that could be easiest thing. Like we say Hadoop FS copy from local, and that's what we do, right? So we export MySQL to CSV using some tool, and we do that. Or maybe we write our software to do that, right? So this is something that you will do. Let's just take this case. All right. Now imagine that this data is, say, of few terabytes, right? And there are say 3-4 parallel databases from which you need to copy the data. There are parallelly 3-4 databases. Now from there you need to copy the data. Now if you take a look at this one, here, when you have few terabytes of data, you will end up spending a lot of time here, correct? Which process will be slower, this or this? Quickly, this is, here we are reading, this is writing, so which one is slower out of these? Write will be generally slower, so it's better to make the whole process as distributed. So what you'll do is, you have HDFS is basically multiple machines, right? So imagine this HDFS, remove this from here. Okay, or let me just draw it here. So please pay attention. So we have, let's say, these 3 machines, okay, which are our data nodes, right? And on these machines, we have also installed node managers, correct? So when we are copying the data, instead of only through one machine, what we'll do is, this table which we are talking about, okay, it'll create ranges of this table. Some of the rows will be copied from here, copied here, copied here. So there will be 3 such processes, okay? There will be 3 such processes happening directly. So this will copy, say, copy first 1 million record, and this will copy second 1 million, and this will copy third 1 million. Okay, in the end you will have 3 files. Okay, in the end you will have 3 files, 1.csv, 2.csv. I'm just putting the names are generally different, so 3.csv. So one table got transferred here. Clear? So you need to run some kind of a logic here, right? Everywhere you'll have to run some kind of a logic which makes JDBC connection and write to local, right? What is JDBC connection? JDBC connection means connecting to a database from Java, right? Everywhere you have to do that. Okay, so for this, we generally use a tool like Scoop. Scoop basically does the same thing. Scoop basically launches a job on multiple machines from which we talk to the MySQL or any other database like Oracle or something else and pull in the data to this machine, which also means that all these 3, there will be 3 connections to your MySQL database table, right? And when you copy the data from there, it's going to basically, this database must accept the login password from this machine. Okay, and if we are not careful, right, what will happen is we'll keep on complaining at this point that, hey, my database was working fine in my sandbox, but it's not working. This is not working in production. Okay, even worse, that if you have, say, 20 nodes, and on, say, 10 nodes, you have given the permission to access MySQL. You have whitelisted only 10 out of 20 machines. which can connect. So this job will run sometimes, this job will not run sometimes. So you will go to the show to the sysadmin that, hey, see here, my job is failing. You go there and you run it, and then it is running fine. And when you want to run it in production, it'll randomly fail. Reason is that only 10 machines have access to the database. So if these jobs are being executed on those 10 machines, all three jobs are being executed on those 10 machines, they'll work fine, while the remaining 10 will not work fine. While you will keep complaining that, hey, this was working perfectly fine on my machine. So if you don't understand that the work will get distributed, there'll be three different computers talking to a database, then what will happen? All right. So therefore, the point I was trying to drive is that most of the work when we do in distributed, though our code will not have this reflection that run this on first computer, run this on second, run this on third. Our logic or code will not be like that. But in our minds, we need to be aware of that part because that will help us debug and get things done in the production environment. Okay. A question from Robin is, in setting up each node machines with container and app master, okay, okay, so what are the, basically node manager, what are the dependencies with respect to capacity planning? What is the assurance that can have maximum tolerance to handle too many client requests during both upfront and on the go? Good question, good question. So, okay, before moving to that, um, was I able to answer your question, Hitendra and others? Because this is is this example clear to all? So we'll be using Scoop in this case. Scoop will be doing the JDBC connection. We won't be doing the JDBC connection. And it is important to know that the work that we are going to do using Scoop is nothing but basically this is what it is doing internally, right? So to Scoop, we'll just tell that here is my database table and here's my output folder, and it'll do the rest of the work. Also, we'll tell Scoop the login password of our MySQL database. So it'll basically internally do that. Okay. Also, we'll tell Scoop that on which column does it need to break down the data. Okay, so that's one thing that we will tell Scoop, and Scoop will do that everything. But the important part is Scoop will keep on failing in the production, and you will have to figure out that why it's failing. Okay, write local means to the local data node, right? Because this will run on node manager. Node managers are generally on the data node. Okay, as in local, instead of local, we can say write to the data node. All right. Yes, that's right, Hitendra. Scoop is in and out from RDBMS. In this example, we have to write code to count the vowels. For example, we have to write a code to count the vowels in a big file. How to write it in Spark, right? So mostly what we will do is we'll break down the code into kind of a group by paradigm, and we will let MapReduce or Spark do the group by for us. Okay, so we'll utilize their framework to do the counting instead of we writing the for loop. Because if we write the for loop cannot be broken down to multiple machines. Therefore, we'll have to restructure our code. Okay. Yes, so Scoop will do this. Scoop will basically take the output folder from us, and there it'll create these files. Okay. All right. Good, good. So that was a brief introduction about the YARN. We did not only learn YARN, we learn about many other aspects about computing. Okay. A question from Alok. So without Scoop, we will have to write our own code to do the JDBC connection to run the data node. That's right. That's right. Basically, scoop is nothing but a MapReduce job. It's actually a chain of things. So it's like this. Um, scoop. So all right, this is you. This is you. This is scoop. Scoop is a command. Okay. All right. Now scoop command will execute the MapReduce command, and MapReduce command will talk to the yarn and then get the work done inside containers. Okay. Okay. So basically, this is you here sitting. You opened web console, and then you execute a scoop command. Scoop command internally, instead of writing its own logic of distribution, it wrote the JDBC connection and other things inside the map function and handed over the map to MapReduce. Okay, it doesn't give the reduce part. It only gives the map part because it only need to run the process on all machines. It doesn't need to aggregate data. Okay, we'll talk about these parts later. So then here what happens is this. The MapReduce internally, MapReduce is a client for Yarn. Okay, MapReduce will ask ask to run MR job. Okay, the MapReduce job. It will give the whole bundle of things. Along with the MR job will contain the logic of MR jar, the MapReduce jar. It will also contain the program written by Scoop, which will, okay, so it's like this. So it'll basically here at this point, the MapReduce will ask Yarn to execute MapReduce along with Scoop and so on. Then it'll basically execute, talk to the node manager. Then there'll be containers. There'll be many containers. Okay, there'll be many containers here. Okay, and then they will talk to the MySQL databases parallelly. Okay, so this is where the three containers. So let me put 3 arrows here. Okay, so this is what happens, and then these containers will parallelly write to the data nodes. Okay, so the same way when you write the SQL query. So I'll just draw here. Okay, so you write SQL query. So here, let's say Hive is there. Okay, so here, okay, here you are sitting here. You fired a SQL query the way we showed you just a couple of days ago. You fired an SQL query. It'll go to Hive. Hive will talk to MapReduce. MapReduce will internally talk to Yarn, and then the flow will happen. Similarly, you launched say Spark command. Okay, so this is Spark console, and Spark console will basically connect directly to Yarn. Okay, it won't go to MapReduce, and this is you. Okay, when you say PySpark or Spark shell. Okay, so here you will open this connection once, and then you will keep on passing more and more commands to the same connection. So this is a long running process. This is batch process. All right. Okay, so yes, so we do need to do anything. Just okay, so yeah, Alok's question is, what is it that we need to give to Scoop? We just need to give the DB info and output folder in and out. Okay, so a question from Noor. Who tells Yarn if computation can be distributed or not? Example, if some data has dependency with previous data, we will want Good question. Good question. That's why we need to rewrite most of our applications. Okay. That's why we want to rewrite most of our applications. So the best way to think of it is this way. Okay. Let's say we wrote for loop earlier, correct? For each vowel for each, what do you say? Okay, I'm going to take a slight deviation. So be with me for a moment. There's some, so usually let's say we have to do the vowel counting, right? So what we'll do for each vowel in the text, not vowel, for each character in the text, correct? Actually, that's what is the next. Update the counters. Okay. So we have all we do is create 26 counters, right? How many vowels are there? 5 vowels, right? A, E, I, O, U, right? So we create for 5 counters. Let's say what we want to do is we want to count the vowels. In classic sense, like the way we program, what we do is we create 5 counters, and then we will go over each character in the text and we'll keep on updating the counters, right? Updating counters means let me just put it as a comment. We say if character is A, then increase the counter 1. Okay, counter we'll say counter 0 plus equals 1, right? And so on. So we'll write the same logic for all the counters, correct? Is it clear to all? Okay. And we'll do the same thing. A, E, I, A, E, I, O, U, correct? So this is what we'll do, right? So if we have to count the characters, this is the kind of logic we'll write. That for each character this is a pseudo language I'm using. So for each character in the text, the if character is A, update the 0th counter, increase the 0th counter. If the character is E, increase the first counter, and so on. There are 5 counters which we have kept, like 5 fingers. Okay, so this way we keep on doing that, and once this is done, we basically print the results, right? This is how we typically program. But imagine the same thing is there in SQL, right? Imagine that this text is such that there is a database table, each table with single column, and each row has a character. Now, how would we achieve it? Let's say, imagine that there is a table with a single column, and each row has a single character. So each cell in the table has a single character, and there is only one column. So what will we do? Imagine that this is the kind of thing that it is looking like. SANDEEP. Now you have to write a SQL query to do this, to count the number of vowels in this. And this column name of this one is, say, C1, right? So what will you do? Anybody? All right, let's take a break at this point, and we can you write the query for this. Okay, let's say the table name is table one, and we have column C1, and these are the rows. Each row has this is the important aspect of distributed computing. This is the first step that we are taking, and we'll learn more about distributed computing as we go ahead. All right, so let's take a break at this point. We'll be back in 10 minutes. Okay, so break for 10 minutes and back by 9:45 p.m. IST. Please post the time in your own time zone. All right, so what we learned in the before the break was that how would we do the counting if the data was in the database tables, right? So in the database, there is a for loop. Yes, remember in some of the SQLs, there is something called a for loop, but that's strongly discouraged. Okay, so basically, you will end up writing a group by clause along with the filter, right? First, you will filter and then do the group by, right? So the way Alok has suggested that we will write a query saying where word is in this, and then we group by the word, okay, and do the count star, correct? So now, once we have, I think this is the best answer. All right. Yeah, thank you, Rajan. Okay. Now, the impo the answer from most of you was that we will write a query like this, correct? We'll write a query like this. Now, there are two approaches. One is this, and other is this. Correct. This one is considered better with respect to databases. And in summary, it's a similar approach that we use in parallel or distributed computing. That instead of going with the for loop, we write something in the form of group by. All right. So you can think of MapReduce as a huge group by system, okay, in which this logic of selecting a key, this is where you selected the key, right? And here you have picked up only those keywords which are in this, and then said that okay, that word will be the group by, right? So first you define on what basis you want to group the data, and then you define on what basis you do the aggregation. Now, MapReduce as a framework, the way you wrote this query, hand it over to database, in the similar way, in case of MapReduce, what you do is you write this logic as a program. Okay, you write this as a separate program, and you write this logic as a separate program, and then you hand it over to MapReduce, and it executes it internally exactly this way. All right, so that's probably the easiest way to explain what is MapReduce. So, and the way we can think of MapReduce is always like SQL query, that what can I group the data based on such that I can get my work done? Or is there any need of grouping? We can just get things with select and where clause. Okay, there's a sole idea there, and we'll talk about this aspect just after this. Okay, so in this session we are going to talk about simple MapReduce. It's very important to understand MapReduce basics because this is the first time you are interacting with the distributed system. So so it's very important to understand it's very important to understand the significance of distributed. So let's take a very simple example. Okay, the way we just did. I think this example was clear to everybody, right? So what we do is we wrote the SQL query to interact with database. In the same way, we interact with MapReduce, writing instead of SQL query, we write maps and reduces. Okay. all right, in the standard algorithms. Okay, so we are going to talk about that now. Okay, a question from David. Isn't the syntax word and count? Good point. It is up to us. This is just the order in which we want the results. Okay, if we put word before, the result will be that word. The word as in character. This is character. So we can say C and C and C. Okay, so if this column name is C. Okay, so here what we are saying that C is second while being printed, while this is first. That's all. There's no problem in switching the order. Good question. All right, now so let's understand the okay. So here, what we learned was that we used group by, and group by internally grouped the data. And you will notice that grouping is important because grouping internally does the sorting and other things. So let's understand the meaning of. Okay. So now the first problem to address is a very simple problem. How fast can 1 gigahertz processor sort 1 terabyte data? This data is made up of 10 billion 100 byte sized strings. Anybody? There's no straight answer to it. So the answer is around 6 to 10 hours. Basically, the main time goes in reading the data from the disks. Okay. So the and basically when we talk about sorting, right? Sorting is basically ordering the data based on certain criteria, right? So ordering the data based on certain criteria. All right. Yes. So shuffling and sorting is a process in MapReduce program. We'll talk about that soon. Okay. So when we sort some data, we basically we first read the data into the memory, and then when you use an algorithm or strategy to order the data. And when we are dealing with humongous data, it takes humongous time to sort this data. Okay, humongous time to sort this data. Now, 6 to 10 hours is a huge time, right? When we are dealing with 1 terabyte data, for me, it has taken around 12 hours on a single computer. Okay, around 12 hours. But for the point here is that we're not looking at exact numbers, we're looking at a range. So 6 to 10 hours is not sufficient. If sorting 1 terabyte data is taking so much time, then it's going to take humongous time to basically do this. Okay, so generally we need a faster sort and we might have a bigger data to sort, and we might have to do it very often. Now, the so sorting is a very important exercise. Sorting is a very important exercise because sorting is there everywhere. Okay, whether when you are searching for something in Google or when you are, say, using Excel or using databases, everywhere the sorting algorithms are being used. Okay, so sorting is kind of the core problem in computer science, and that's why there is something called sorting benchmark computation, which Google won on 8 September 2011. And that's where Google proved that using MapReduce, they were able to, for the first time in the history, they were able to sort 10 petabyte data in 6.5 hours using 8,000 computers. All right. So they proved it publicly, and they proved it publicly that sorting was they basically won that international competition of sorting benchmark. Now, We talk about sorting. The sorting is everywhere. Sorting is in every SQL query, directly or indirectly, we are doing sorting. For example, when we create indexes on your table, what is it? It's a sorting. And when you create indexes on your table, what is index? You have a database table, which is columns and rows, right? So what you do as index is you pick up the unique values and keep the reference of where all in this table, this unique value is existing. For each column, when we are creating an index, we create index on one column or multiple columns together. We take individual value and then sort the individual values and keep it indexed the way you have seen in the backside of the book. There is generally an index where the keywords are sorted, ordered, and there's a reference that this keyword was found there. So that's called an index. So in database table, the index are created by picking up the unique value from a column and then keeping it somewhere, just like we just did. We basically, index preparation is a sorting exercise. Okay, index preparation is a sorting exercise. Let me just share the slides with you. Okay, okay. So a question from Maru, can you explain clustered and non-clustered index? We can talk about these outside because that will kind of deviate the entire discussion. Here we are focusing, we're talking about index only from the perspective of understanding what is an index. So every SQL query is impacted by sorting, where the where clause, for example, when you do where clause, select star from this table, the where clause basically gets impacted by the indexing. Similarly, group by, what is group by? Group by is nothing but sorting. Group by is nothing but sorting. The way group by works is you order the data first and then you keep on going from the top, and as long as it's the same value, it keeps on grouping together, and then as the value changes, then it starts a new group, right? So group by is nothing but sorting and then followed by grouping. So basically group by internally is sorting. Okay, next is joins. Now, joins is immensely enhanced by sorting, right? So if you have two tables, you're trying to join them, then if the data is sorted, then suddenly the joins become really fast. Okay, so almost every SQL query uses one form of sorting or another. And most of the software engineering is actually SQL queries, right? Most of the IT, most of the information technology is mostly SQL, right? Similarly, distinct, order by, all of these are nothing but sorting under the hood. Most of the algorithms depend on sortings, right? Therefore, therefore, sorting is one problem that is solved by MapReduce. Okay, Google's MapReduce basically solve the sorting problem, and the same was implemented by Hadoop, and that became basically a sorting framework. So the way MapReduce is for us is basically a programming paradigm to help us solve big data problems, specifically sorting intensive or discrete intensive. Okay, discrete intensive. So if your job does not have any sorting involved, there's no grouping, but it's a discrete intensive. Remember our job whereby we were trying to resize a lot of images. That was sorting intensive job. Okay, so that was a sorting intensive job. Okay, sorry, I'm really sorry. The job that we talked about earlier, the image resizing job, it's a discrete intensive, not sorting, because there was no sorting involved. Okay, we were most of the time was being taken in reading the data from the disk, right? So MapReduce is great for the situations where you can break down your problem into sorting, or if your problem involves reading the data from the disk, and reading the data from the disk is becoming the bottleneck for you. Okay, so in very simple words, the way you write in group by, you have you specify the column on the basis of which you're grouping the data. You specify mapper. Mapper converts the input raw data into key and followed by any value. It is up to you what you want in key, what you want in value. Key means the data will be grouped based on that criteria. All these values will be grouped based on that criteria, and reducer dictates how these values are going to be combined for each key. Okay, so basically you can actually break down most of the problems into MapReduce. Okay, so so MapReduce is not alone for Hadoop. MapReduce as a framework and a paradigm is adopted, is a technique is adopted by many systems. Like the way SQL was adopted by many, similarly MapReduce also is adopted by many. So MongoDB, CouchDB, Cassandra, Spark, they all kind of use some form of MapReduce. Okay, mapper and reducer in Hadoop, you can write either in Java, Shell, Python, or any program, any existing program you can use in as mapper or reducer. So we write two pieces of code, mapper and reducer, instead of writing a single SQL query. Here we basically write two pieces of code, mapper and reducer. All right. Now, so let me answer your question. I've not answered your question for some time. So a question from Timisha: is shuffling and sorting is process in a MapR program? Yes. Where is SQL query normally located? Can the sorting, okay, where is the SQL query normally located? So here I was saying that the client, basically I was taking an example of standard databases where the SQL query would be provided by the client. Can the sorting of 1 TB data be distributed to more than one computer? Can the sorting of 1 TB data be distributed to more than one computers? Of course, of course. Okay, okay. So this is the part I'm going to take up, Robin, next. Okay, and Timir. So, all right. Could could we share the new slides? I think I've shared already. And Grisma, if sorting is done on multiple computers, on what basis? Okay, let me just see. Is this the right one? Yeah, it's the right one. Okay, all right. A question from Noor. How sorting would work in distributed system? And that's a thing I'm going to discuss. Okay, we are going to talk about that part. Okay, I'm going to explain MR, so I think we are going in the right direction. That's right, Sachin. Sorting means generally to arrange data in ascending or descending order. Okay, order, basically sorting means ordering the data. All right, that's the one that we are using. All right, so sorting is the most important phenomena in the computer science. Okay, and let's take a look at how does MapReduce look like. Okay, all right, so I'm not able to look at this one. Sorry, it was 9 MapReduce basics that has no text. Oh, I see, I see, I see. Oh, okay, okay, okay. So I'll just take note this. I'll just make a note of it. Okay, great. Thank you, Noor, and thank you, Bintao and David, for the question. Let me just make a note of it. All right, wonderful. Let's talk about MapReduce. So MapReduce, in very simple words, we write two pieces of logic. Okay, we write two pieces of logic, and we basically we basically, where is my other logic? Where did it go? Oh, here it is. Okay, we're going to spend the decent amount of time on the MapReduce. All right, so basically in MapReduce we write two piece of logic. One that tells on what basis do we want to sort our data. Just like in SQL query, we define on what basis we are grouping the data. What is that key on the basis of grouping the data? Instead of just telling the key, we can write, we will have to write a program, a piece of logic, which could convert any raw data into a key, right? In case of, let's say, we want to group the data based on the character, so it that the mapper phase will break down the input raw strings into character, character and some value, right? So basically, the piece that gives the key value is a program. Unlike SQL, in SQL we just can only deal. Let's say we had to we had to encrypt the data, or let's say we had to do the MD5 checksum of that particular string as a key. Imagine that you have a lot of files and you wanted to deduplicate them. So for each of the file, we'll have to compute the group by. For group by, we'll use the MD5 checksum as the key to deduplicate them, right? So that kind of complex things cannot be done in SQL, because there we can only do a very basic kind of column selection. But in case of mapper, the logic of in case of mapper, this phase of selecting the column could be really, really complex, right? So so basically this portion is what we call mapper. We'll write a program which will give out, we will specify this is the key, this is the value, and we will write our function, our custom function, to group all the values for a particular column. Okay, so what is CouchDB, Cassandra? Can you have me an example of each? CouchDB and Cassandra is a database which runs on multiple computers parallelly, and they are separate NoSQL databases in which we can store tables, or we can store a humongous data in them. Okay, or MongoDB. No, it's the same as CouchDB is very much same as MongoDB, and Cassandra is more like HBase, whereby you have table, you have columns, and you have rows. All right, good. So basically, the idea is that we write two pieces of code. One gives you key value, other groups that key value. And now what key, what value, it depends on what basis do we want to group the data. That's what our mapper function should give. Okay. Now, please note that it's not mandatory to have reduce phase. Okay, it's not mandatory to have reduce phase. You could have just the mapper phase as well. Okay, so just like in many select queries, you don't have group by. In the same way, you may not have the reduce at all in some phases. For example, image resizing was an example whereby we were taking an image, resizing it, and saving it at the disk. Right? In those cases, we don't have to have the reduce phase. Correct? So let's talk about this now. MapReduce is going to run on multiple computers. And remember, when we saved our data in HDFS, it was in many computers on many data nodes, right? Every data node was having the HDFS block. Every data node was having the HDFS block. And imagine that there are three data nodes, 1, 2, 3, and they have the HDFS block. Remember? So now when we run the mapper logic, it's going to run, when we run MapReduce job, and internally, whatever we define in mapper logic, that mapper logic is going to be executed on all the machines. But before it gets executed, the raw binary data of HDFS block will be converted into records. Okay, will be converted into records. This is called input format. We'll talk about it in more details. So the raw data will be converted into records by the way of input formats. We call that in split. Split is nothing but bunch of records. If it's a big text file, it'll split 0 will have some lines, complete lines, not sliced lines. While HDFS block will be raw, there could be slices, so there could be a little bit of transmission here. So split 0 contains some of the lines. In case of plain text, or in case of, let's say, other records, it would have some connotation of record. So split 0 will have some record, split 1 is having some record, split 2 is having some record. Okay. If there are each split is being prepared from multiple blocks, then the data transfer would be there. Okay. Now the map phase takes the input from split 0. Map phase, the mapper function takes in these records, and it gives out key and value. It gives out key and value. These key and values are sorted parallelly on these machines. So this function that you wrote, it takes the input data and gives out. At the time of writing, it doesn't matter to you the way SQL query, when you wrote SQL query, it doesn't matter to you whether it runs on one machine or many machines, correct? Or it's running in memory or in the disk, right? It doesn't matter. So in the same way, here when we wrote map function, we just wrote this small piece of logic which converts raw data into key value pairs. It converts raw data into some key value pair. Raw data as in these are the text lines. It needs to convert it per character, per word, or whatever. So those key value pairs are locally sorted. Okay, and then they are copied to a single machine and again merged here. Merging the sorted data to produce sorted data is far more easier, right, as compared to sorting the humongous data. Okay, so here the merging of sorted data happens, and after that, once the merging has happened, then the reduce is called on each key. Same key could exist here, 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 and it could be sorted here, it could be sorted here, it could be sorted here. Same vowel could exist here, 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 and everywhere the grouping will happen, the sorting will happen, and then it'll be merged here, and then finally the group by is happening here. So sorting is happening here, then the group by is happening here. And once the group by finishes, then the result will be saved in the HDFS. Okay, so this is the very high level view of how MapReduce works. So you wrote this logic which takes some data, gives out keys, and then here those keys get sorted, those keys you get sorted, those keys get sorted, and then they get copied to this machine, separate machine, or could be one of these machines where these keys are merged, and on the merged data, the reduce is called. Okay, where does the merge happen in memory? Not really, not really. It is happening in the disk mostly. Okay, so you can imagine that these are the three files, file 1, file 2, file 3, ordered based on certain criteria. And then when we merge them, it's basically using this, the in-file merge. Read one line from each of these files, merge them, save it in another disk, append to another disk, then read the second line from each of them, then merge agent, pick the one which is smallest and save it in the output. Okay, that's how it happens. All right, so it doesn't happen in the memory. It happens mostly through the disk. Okay, so that's the beauty of it. So while sorting the data might require to hold some amount of data in the memory, but merging doesn't need to hold the data in the memory. I'll show you that. Okay, so other way to look at it is that if you want to have a sandwich, you want to prepare a sandwich, you create a function called map, which cuts each vegetable into pieces. Okay, so this function called cut into pieces happen on this, and this, right? And then in the reduce phase, all of these things are merged together into the sandwich. Okay, so the work could happen by 4 or 5 people parallelly. First person just slicing this, second person slicing this, third person slicing this, and so on. This could happen in parallel. While the reduce will have to bring things from everywhere. Therefore, it could be little reduce could be basically using all of this. So reduce creating one single sandwich would be done by one person. Okay. Though there could be multiple persons preparing sandwiches out of this parallelly. Okay. So question from Noor is, in order for merge to happen, the single node must have the capacity to hold the merged data. You mean the disk-wise? Disk-wise, yes, but not in the memory. Okay. Also, as in when the data gets merged, it gets saved to the data node, and therefore it doesn't need to all the time keep the data with it. So going back here, so if you take a look at this, right? So here the output of merge is stored uh, here temporarily. This file will get copied here. So yes, these 3 blocks of file need to be kept here on this. Therefore, this machine must have that much of disk capacity. Okay, this machine needs to have that kind of disk capacity. A question from Grishma is that this merge happens on which node? It could happen on either of them or could happen on third node or fourth node, a separate machine, based on the availability of the machine. Okay, we'll talk about the code in a while. Okay, we're going to talk about we're going to show the code in a while. Don't worry. All right. Now, so those who wants to take a look at the code, I would suggest them that. Okay, so you could take a look at the GitHub repository if you right away want to take a look at the code. Okay, but I would suggest that we'll go into the details of the code in a while. Okay, so here is the code in Python. Let's say character frequency, the one which we were talking about. It was very simple, right? So it reads. Okay, all it does is okay, and yeah. Okay, you could take a look at the character frequency here, and you could take a look at, say, there are a few more problems there. And if you want to take a look at, say, Java program, you could take a look at here. Okay, so this is, say, the character counting program. So this is the Java mapper. I'll just show you Java mapper in case you are hurrying. So all it does is for the provided text, it It basically gives out the key and the value. This is the key and this is the value, and it saves it in the context. So for each character in the line, this is what it is going to do. All right. So don't worry, I'll go into more details about this, or you could just go over the code. All right. So this is a better way. All right. So if you want to take a look at it, you can take a look at that. Okay. A question from Robin: can two or more data nodes share storing, holding the big merged data output from HDFS? Hmm. Okay, I think this question will get answered very soon. Don't worry. Okay. So MapReduce will basically save different files. If there are multiple reduce phases, it'll save different files. So parallelly, the data will be saved to the disk. Okay. Now, here's a very simple question to all of you. Question is, if you have the plain text file containing hundreds of textbooks, how would you find the frequencies of the words? What is frequencies of the words? Basically, we have to find the unique words and how many times each of those unique words in this text are occurring. It's an open question to all of you. Use whatever technique you want to use, whether you want to use database, you want to use programming, you want to use Python, you want to use Shell, you want to use any other technique, please suggest a solution. Say you have hundreds of textbooks, around 500 MB of data. How would you find the frequencies of the words? Okay, finding the frequency of the words is finding those unique words and finding how many times each of these unique words in this text occurring together, occurring there in the text. Okay. Say, for example, in this text on the screen, right, U is occurring how many times? 1 and 2. If is occurring how many times? Only once. Have is occurring how many times? Once. The is occurring how many times? 1, 2. Yeah, 2. Plain is occurring how many times? Okay. 1 times. Text is occurring how many times? So we have to, this way, we have to find the frequency of each of the word in those hundreds of textbooks. What will be your strategy? Okay, consider it as a real question, because if you look at this frequency analysis is everywhere. Okay, frequency analysis of the text is everywhere. So in case of Amazon, when we were doing the book, right, in the book we want to generally display the which protagonist or which character appeared where in the book. So that was essentially a frequency computation. Okay. Similarly, the plot in book, if you go into the book section, it shows the character plot, which character has come where. Okay, that one is done using the frequency computation of words. Similarly, when you take a look at the history, or you want to say understand what kind of language is being used in a particular web page, you generally do either the character frequency counts or word frequency counts. Okay. All right, very good answers. We need to read the text and put each word into a buffer and make its counter based on the appearance. Okay, okay, good, Grishma. Point from David is the 500 MB even Access DB can handle with a group by. That's right. That's right. Okay. Prashant's question is using doc to word. Okay. Doc to Word, what does it do? Okay, is there a, I would love to understand that. I see, I see. So here we are just basic talking about counting the word frequencies. Okay, word frequencies as in just finding the unique words in this page, and unique not in terms of the language processing. Spacey you would probably use when it comes to removing these the, and all, or maybe understanding the word. Here we are talking about a very lame kind of processing, whereby we're just counting the frequency of words. Yes. So one answer was using the database. Other answer was from Grishma that we'll read the text, put each word into buffer and make its counter-based appearance. Okay, good, good. Any other suggestions? Alok, Aniket, Bintao, David, Garvin, Grishma. So this used to be a very favorite question which we had at Amazon when we hired people in case of to handle the workload. So we start here and we keep increasing the size of the text. Okay, from 500 MB we'll move on to 500 gigabyte. Okay, then we'll move on to 500 terabyte and then see how it goes. Okay, so Hitin's answer is distribute the workload amongst nodes, combine the result from each node. Good. David's question is more interesting if you would have all the books in the US Library of Congress. Okay, yes. So that's the next question that I generally have. Okay, getting the first approach and then moving on to the next one is something that we do again. All right. Okay. So yes, slide is having the answer MapReduce, but we are saying that without MapReduce, what will you do? Correct. So Rajan's suggestion is they split books into small files. Then on each split, on each file, split the word, sort the word on multiple boxes, and then count, right? But after doing that, right, after sorting, you'll have to merge the thing into one machine, correct? All right. So I think I have all the approaches from you, the one that I'm going to talk about. Okay, correct. Right. So this is, thank you, Maruk. So we can have multiple threads, right? So the most simple one that we all end up doing is create a frequency hash table or a dictionary, right? Create a frequency hash table or a dictionary, and for each word in the files, increase the frequency in the hash table. If no more words are left in the file, print the hash table, right? Here is the Python code on the, it's a functional code. There's a word count hash table. For word in the file dot read dot split, if the word not in word count, then do word count word equals 0. Meaning if the word is not found in the dictionary, this is the dictionary as in, here we are keeping the counters. Okay, for each word we keep a counter. So if the word is not existing in this dictionary means something where we can have key and values. Okay, so this dictionary is where here basically we are updating the word count. That's the approach which Maruk has suggested and Grishma has suggested and some of you have suggested. Okay, and this is a classic approach actually I will do in case somebody asks me to do it over 500 MB. Okay, so basically we'll read the data from the file programmatically and do that, right? But actually most of us will not do this way. Most of us will either use database or use the file system. Okay, so here, let me just go back here. So question here is that this is the algorithm. Start, initialize a dictionary or hash table, right? This is the dictionary in which we'll keep the counts. Now, then we read the next word from the file. If any word is left, no. Then if it is yes, then exit. Otherwise, find the word in the dictionary. Does the word exist in the dictionary? Yes, then we do here, otherwise here. So question is, do you see any problems with this approach? Do you see any problems with this approach? Yes. Thank you, Noor and Alok. So it wants scale. Yes, thank you, Maruk. IO operations are slow. This is just single machine execution. Thank you, Hitendra. Time consuming to read each word after another. Correct. All right. So here the biggest problem is the memory overflow. The biggest problem is the memory overflow. Okay. And that's basically the reason. You cannot process data beyond the RAM size. You'll be amazed to know that that was the last one of the problems that I had. And I was amazed to know that even very senior engineers, when they hit by the memory limit, they kind of blame the resources. Okay. For example, the first, if you have heard about the Mario game, it has few kilobytes of memory, and still the Mario game was pretty good, right? So, so, so basically, most of the approaches that we talk about are very memory intensive, and this was one of the case. So, so I remember even for a few terabytes of memory, uh, this. So I have a couple of more stories to tell here, a couple of more instances to tell specifically. One is the case in case of one of my projects. So our program was processing 200 terabyte data, and we needed to do the same hash table based computation, and because of which the memory consumption was going up to 4.5 GB. So the sysadmins did not allow us to execute it on the cluster. And at this point of time, we thought that okay, 4 GB they must give us, and therefore it's not our problem. But our problem was there. Our problem was there that our program was consuming 4 GB. As engineers, we must figure out how to live with memory restrictions. How to live with memory restrictions, because the general strategy that we have in mind, and we say that okay, we can't live with, we must have the bigger memory. So it's a very important lesson which I've learned a really hard way, that no matter what happens, a general thought that you will see is that now we have bigger systems, bigger hardware, that then we should not have any memory overflows. But the fact is, we do have memory overflows. Okay, we do have memory overflows all the time. So do not take memory for granted. All right. So we must learn how to deal with lesser memory. Okay, even in today's time, where you have gigabytes of memory available. We had one server that we had was 200 gigabyte of RAM. Okay, still they did not allow us to execute beyond 4 GB be beyond 200 MB. They said that if we do that, then all the users would kind of suffocate. So it's a very important lesson that I learned, that never take the memory for granted. And that the game about most of the distributed computing is two bottleneck that we cater to. First bottleneck is the discrete speed. Second bottleneck that we cater to is the RAM limitation. Okay, keep this in mind all the time. Okay, I had a recently one of the instructors of one of the users of our cluster, right? So they were basically consuming a lot of RAM of the cluster. So and still they needed more RAM. They were using like 16 GB of RAM per process. Still they needed more RAM. And they were kind of continuously blaming that, oh, system is not great, this and that. Then I had a discussion with them that the way they are using the way they are using the system is completely wrong. This is not how we do the distributed computing. They were still living with the fact that we are living in a the virtual box kind of thing, where we have 64 GB RAM and we can do everything, right? So, but in production environment, this is a very important point, where when you will build the entire cluster, and you have built this marvelous set of program, and then when you put it in production, they'll kick you out of the production, right? The moment the RAM goes beyond 1 GB even. Okay, so keep in mind that whatever we do from now onwards here, we will keep the memory as one of the primary criterias. All right. So no matter whether we have quantum computing available, whether we have these massive amount of memory available, the RAM is going to be always the bottleneck still. Okay. Sorry for the big rant. Yeah. Now, so in this case, the RAM is the something that basically overflows. Now, the second approach, the one of you suggested, was using SQL, break the books into one word per line and insert that one word per row in the database table, right? Then call this. Is it clear to everyone, this approach of using SQL? No? Oh, I think everybody's gone to sleep. Okay. I think Prasant could have gone to sleep because he logs in from Singapore. It would be really late there. I see, I see. For Noor also, it's pretty late. Interesting. Okay. All right. So yeah, the only way I can suggest is that start asking question, and that will keep you awake. Okay. Now, third approach, this is the second approach. And the third approach is using the Unix pipeline. Okay. How many of you are comfortable with Unix pipeline? You can raise the hand. So we talked about two approaches. One was programmatic approach, where the RAM was a limitation. Second approach, we talked about the SQL. We have not talked about the limitation yet. Okay. So only Sachin and Grishma is fine and Noor is fine with respect to Unix pipeline. Okay. Prashant is not. Okay. All right. So I'll give you a really refresher, a quick refresher, so that you all get motivated to actually start working with the Linux. Okay. Vintao, are you comfortable with the Unix pipeline? Everyone? Yes. The pipe, the vertical line that you have just above the enter key. Okay. All right. So I'm just going to give you a really quick refresher, but I will strongly recommend all of you to basically look at this. Okay, I created this Unix tutorial. Okay, just take it out. Okay, here you see this one has a very good assessment, so you must try this. If it's not clear, just let me know. Okay, so you basically try the word count exercise here. Okay, on Linux. So basically checks everything. All right, so now I'm going to talk about this Unix pipeline really quickly and see if I could help you refreshing. All right, so first of all, the program takes input from you, correct? Every program takes input from you. Then the program also prints some output to you, right? Then program can actually talk to another program. The program can give output as input to another program if we use the pipe command like this. Okay, so in Unix we could chain multiple commands together like this. Okay, so I'm going to show you this command in parts. All right, I hope that'll clear. All right, so here we go. So here is the command. All right, this is the first command. What it does is it prints the data from this file onto the screen. Okay, so I'm going to take a small example. Let's take a case of, yes, David. Okay, so you have raised hand in order to mark that you know Linux. Okay, so I'm going to just decrease this size of the window. All right, so we have say ls command here. Okay, all right. So what is ls? ls basically prints the list of files on the screen. Okay, now do I have small.txt? Can take a look at small.txt. Is the font big enough or should I open a new terminal? I think I can open a new terminal for you. Okay, let me just open a new terminal. Right, this is good. This one we can. All right, so we have say any command like ls is giving some output to you. Similarly, we have say small.txt. If you want to take a look what is there inside a small.txt, we could say cat. All right. So this cat command basically prints the data onto the screen. All right. Here, now let's say there is a command called sed. Okay, there's a command called sed. What sed does is it basically finds and replaces a particular word line by line. Okay, so let's say we want to replace space with the new line, space with the new line, and want to do the globally. Okay, so what we did was the the output of cat, the output of cat went to sed, the output of cat went to sed, and then it basically replaced every space with new line. Okay, just like Control F, and you say /n means new line. So you can see that it is one word per line. All right, is it clear till here to everybody? Prashant? Okay. Subbu? Shravanti? All right. Okay, please feel free to question me because I may not be able to look at the things from your perspective. Okay. So we use SCD to replace space with new line. Now the next thing we do is we basically sort this data, or let me just convert this from uppercase to lowercase, right? And let me just show you some more things. So this command can be executed independently also. Let's say this. So anything you type here, right, is going to print back to you. So it reads from you, prints back to you. In the similar way, this tr command is reading the output of this whole bunch of command, okay, reading the output of SCD actually, and then doing the replacement of capitals with small. Okay. Now the next thing we do is we use a command called sort. It sorts the data like this. You can see it has sorted the data line wise, and afterwards we use another command called unique -c. Unique doesn't sort the data. Unique expects you to give the data which is already sorted. -c basically gives you the counts as well. So you can see that it has given the counts of every record. Okay, we can do further things like we could also do sorting again. So this time you can see that this the has occurred 6 times, while I think the empty lines are there 4 times, and the this is 3 times, and so on. Okay, good. Is this chain of command clear to you? Using this chain of commands, the pipes, we are able to do the word count. Those who are new, is this clear? So first one is just reading the data from this file and printing it up on the output stream. From the output stream, since we have put the pipe, instead of the output stream coming to us, it goes to SCD. It goes to SCD, and then SCD does is it replaces spaces with new line, and then the tr command replaces capitals with lowers. Okay, these, how many commands are there? 1, 2, 3, 4, 5, and 6. Okay, so basically this is what is happening here. Let me, okay, sorry for the new line. I'll just convert it into a single line. Okay, all right. So is it clear to everyone? You'll have to create a small.txt. You can use Pico and say small.txt and write something in it, into not Pico, Nano. Okay, Nano. So you could write anything into this. All right, should we move ahead? So actually, the lot of work can be just done with Unix commands. Then let me, now the sort out of this, which one is the command which is doing the most intensive work? Cat, SCD, sort, or unique? Okay, cat is reading data from the file. So the CPU intensive job, which one is the CPU intensive job? Correct, correct. So sort is the CPU intensive job. And discrete intensive job, which one is discrete intensive job? Correct. So this is discrete intensive, this is CPU intensive. Question from Vinta, if the file is big, I can use cat here? Yes. Cat, it's going to take too much of time if the file is really big. You can use, but it's going to take too much time. All right, now there is one more thing that we're using here. We are saying des capital S and 1G. Those who don't know this part, this is a very good trick. Good trick in the sense that if you are sorting some data and you want to utilize disk, and your sysadmin has told you that don't use more than 1 GB of memory, just use this command. So sort will basically use only this much of memory. Okay, sort will only use this much of memory. All right, so these are the few tricks with the Linux. Now Linux or Unix. Okay, so question from Alok is the same command like Unix in HDFS, pipeline in HDFS? Not really, not really. So we can't do that here. Okay, we'll talk about that part. Okay, so this one is absolutely local. It has nothing to do with Hadoop. And before Hadoop, this is what we used to do. Let's see, unique basically, if the data input data is ordered, then unique basically takes the ordered data and then figures out what is unique in the ordered data. So unique commands hard requirement is that the data need to be sorted. Otherwise, it gives weird output. It gives wrong results. So -c means display the counts. Display the counts of unique. Now, the problem with approach 2 and approach 3, what is the problem with these two approaches? Approach 2 was SQL and approach 3 was Unix. In Unix, we have overcome the memory limitation by restricting it to 1 GB, while the while in SQL also the memory limitations are overcome by the SQL engine. Okay, okay, a question from Robin, just curious about possible use case. In a MapReduce sorting mechanism, can we apply how to set up search filtering from index data as input and feed the output into GUI front end, like a search engine approach for processing past data? For example, at MapReduce, we have Unix command like this, while in GUI front end, where it is mapped, we'll just type the search word count equals 6. Good. So in those cases, what we do is we basically prepare these indexes in the background and keep it ready. And the web application basically looks in the index. Okay. We generally do not interface the end user to MapReduce because MapReduce has inherent delay. Whenever we have any of the batch processes which handles humongous data, there is going to be a delay. So what we do is we keep this word count ready either in the database or in some other form for the end user. Okay, that's how we generally do. Okay, a question from me to you, all of you is, do you see any problem in Unix and SQL kind of approaches? A question from Mehruk is, what mechanisms are used for faster search normally? The mechanisms that we use for faster search normally are basically what we do is we set up a separate server which does in which we maintain the index of the data. So all the services in your organization will keep on submitting the documents to the central service, which maintains the index of data. And then whenever somebody wants to search, they basically looks up at this server and give you the result. So earlier we had to build our own long back in 2003 or so at DESHA, but now you can build it using Solar. In our case, in case of my previous company, which was into document management system, it's called T-Bits Global. There, what I built was basically Lucene-based search on the document as well as on the database records. Okay, so we use either now Lucene is called Solar. Lucene is basically a part of Solar, SOLR. That's generally the tool people. It's kind of a de facto for searching. Okay, I hope that answers your question, Maruk and Robin. That's right, Noor. So in case we are constraining the memory, in both the approaches, there will be too many disk reads, and it will also affect the CPU cycle. Wonderful set of answers. I think we got the answers already. So the moment data starts going beyond RAM, the time taken starts increasing, and the following become the bottleneck: CPU, disk speed, and disk space. Okay, and okay, so basically these three becomes the bottleneck. All right. So the way we solve the memory issues with SQL and Unix is, in Unix we used capital S switch in sort. In sort we use the capital S, where we said that use only 1 gigabyte of memory, while most of the databases already have the RAM constraint. So most of the databases take care of the keeping the data in the disk instead of the memory. And most of the databases use a B-tree kind of a search, which is basically mostly disk-based. Okay, so the moment data starts going beyond what can fit in the RAM, the time taken starts increasing, and the following become the bottleneck. Now, what is the next step? The next step is use external search, external sort. This is a fourth approach, and this is the approach which we used to use earlier before Hadoop came into play. We will split the files to a size that fits into the RAM. Now we'll use either of the previous approaches, 2 or 3, to find the frequencies. I think this diagram will make it more clearer. Okay, let's say there is a launcher, and some of the one file part we send to machine 1, second part we send to machine 2. Let both of them do the sorting and give the results sorted by the key. Okay, here this data need to be sorted. Okay, along with the frequencies, they need to give the sorted data. Otherwise, what would happen is merging will become really big issue, and then this is the result we'll get. Okay, so basically this was the fourth approach that we used earlier, and it takes around O(n) time. Big O(n) time means the order of n time. If n are the records, time is going to be proportional to n records. If it is taking 1 milliseconds to merge one record, it will take n milliseconds to merge n records. That's what big O notation means. So it'll take O(n) time to merge sorted records, or the time is proportional to the number of records of the elements. Okay, so we'll continue from here. We think about this approach, and we'll think about we'll discuss the shortcomings of it and how MapReduce or Spark or any other system solves these shortcomings. Okay. All right. There are a few questions. I'll answer these questions and then we'll call it a day. So we'll continue from this point tomorrow, but now from now onwards, I'll just answer your questions. Okay. If you want to stay back, you can stay back. All right. Um, question from Maruk was that what mechanisms are used for faster search normally, like in the web apps? So generally people use Solar, SOLR. A question from Bintao is, if I want to show parts of the text, how can I add the command to the end of the code? We could use either more, pipe more. You could do pipe more here. I'll just show you that part. So if let's say you want to just show parts of the text here like this. So here you could say pipe more. More is nothing but another program which takes the output from the entire thing and starts showing you paginated way. Okay, that's right. Now a question from Sachin is how you say the memory problem is solved in Unix and SQL approach. Yes, that's what, let me just explain to you. Going back here, if you see here, when we say cat, it doesn't load the data into memory. But when we say SCD, it again doesn't load the data into memory. It processes data line by line. Then when we use sort, then sort loads the data into the memory. So to constrain sort not to load beyond 1 GB, we are using this switch dash capital S and 1 GB. Okay, so this is an important part. Now a question from Noor is, if we constrain the memory, then lots of stuff swapping. That's right. That's right. I think that we discussed. And a question from Maruk is, what about file searching mechanism? How do we fasten the process? Uh, do you have any idea? File searching mechanism in the file system? Okay. That again, you can either use Lucene or you can use the locate command in the Linux. And there are few more commands that you could use. A question from Alok, sorry for little deviation. What is the role of Zookeeper in Kafka producer and consumer? So basically track using Zookeeper. So all the broker, so basically Kafka runs on multiple machines and each service of Kafka is called Kafka broker. Kafka broker handles the individual load and Kafka brokers interact with each other by the way of Zookeeper. Zookeeper, you can think of it like a whiteboard. All the Kafka broker register their name on the Zookeeper. That's how it happens. A question from Jay. Uh, Sorry, I might have missed your response before. I might not be able to available next weekend as I might be traveling out of town. What is the best way to catch up what I miss? The best way I would suggest is the best way to catch up would be using the studio recorded ones. Okay, because what happens is the same discussion what we are having right now, if you listen it later on, it will be very boring for you. Okay, because it'll be too slow. It'll look too slow. So the general way is if you miss out on some of the sessions, just go through the studio recorded short videos and then attend the questions. In case you really want to just take a look at what happened in the session, you could just skim through, or maybe some people prefer that they increase the speed of the video to be twice, and they listen to the video, the live sessions. That could be another way. A question from Robin regarding the upcoming session webinar for anyone unable. We will be storing this and group chat questions and answers portion on the right side. Okay, okay. Let me keep this in mind. Okay. All right. I'll just see if we could use Q&A instead of this because Q&A, I think it is recorded there. Okay. A question from Sachin. Can you again repeat? Okay, I think this I discussed. Okay. All right. A question from David. When will we get an actual example utilizing all of these tools? Sure, sure. Let me just, I think easier way would be to do it after Hive, because those are the more practical tools. These are a little bit of foundation and the science part of the engineering. Okay. Okay. A question from Noor is that if you're scheduling on Thursday, I would request to please confirm in advance. I can prepare myself mentally for a sleepless night. Okay, sorry. So I'll just make sure that I will inform you probably on Monday. Okay. And or maybe tomorrow itself, I'll try to do that. Okay, a question from, all right. Okay, in SED, what does the capital E means? Capital E means that we are going to use a regular expression, E for expression. Okay, so that's how it is. Slash n is a regular expression, therefore we are using capital E. Wonderful, wonderful to have all of you in the session. These were wonderful set of questions. I look forward to see you tomorrow at the same time. Bye bye, have a good day. All right. Thank you, Subbu, Shavani, Sachin, Robin, Ravi, Rajan, Prashant, Jay, Hitendra, Godwin, Bintao, and Aniket, Alok, Alvin, and Grishma, and David. Okay. So great, great, great to have all of you in the session.